Here I'm going to be looking at a Leaving Cert Pass paper question from 2020. It's paper 2, question 3 on trigonometry. In a typical trigonometry question, we're given a set of triangles. This time we don't really need to work them out. And we're asked to find one of the sides of the triangle. So we're asked to find how far F is from the base of the pole G. So effectively we're just asked to find that there. Now, with the triangles, if they're not right angle triangles, then we're probably going to be using the sine rule or the cosine rule. So we need to keep an eye out for that. We're going to be dealing with this triangle HFG. And from now you can see that there's not a lot of information given in the question based on that triangle. We're just given one angle. That's not going to do for now. So we're going to have to use one of the other triangles to work out some information about it. We have one angle. We need to know one of the sides. So what we're going to have to try and do is work out some of the other angles. Now, what I might do is use the triangle HEF, because we've got quite a lot of information about that. We know that this angle here is 35. We know that this angle here must be 128. The reason that is because it's on a straight line, so that in total must add up to 180. So 128 plus 52 gives me 180 for that triangle there. So that's 128. If that's 128 and the other angle HEF is 35, then the angle EHF must be 180 minus 35 minus 128, which is 17 degrees. So that has to be 17. Now I'm going to use the fact that that's 17 and that its opposite side is 6, and also the fact that the angle HEF is 35. So ignoring the triangle on the right, I'm just going to say that this angle and its opposite side in the sine rule are in proportion to this angle and its opposite side. That allows me to work out the length of the green line there. So HF over the sine of 35 degrees is equal to 6, which is EF, over the sine of 17. So I can just rearrange that formula. 6 times the sine of 35 divided by the sine of 17 degrees gives me the length of the line HF. So I'm just going to work that out, rearrange for HF, and plugging that into the calculator. I'm asked to give our final answer to 2 decimal places. So that's equal to 11.77 meters. Okay, so that there is 11.77. I can use the sine rule again, provided I know this angle here. If I can work out that angle, and I can work out this angle, then I'll be able to use the sine rule. So what we're going to use is this lower triangle, which is a right angle triangle, work out this angle, and then I can get the green angle from that. I know that this angle is 5, that angle is 90, so that's 95. So that angle there must be the difference between 180 and 5 and 90. So 180 minus 5 minus 90, that angle there is 85. That angle there is 85, and the total angle there is 180. The angle in green there must be 180 minus 85, which is 95 degrees. Now that angle is 95 degrees. Now that angle is 52 degrees. The angle up the top here must be 95 plus 52 subtracted from 80. It's going to be 180 minus 52 minus 95. It's 33. I'm just going to use the sine rule again to work that out. (11.77) for the sine 25 degrees. As I did above, F, G, just rearranging, put to 11.77 to sine 3 for sine 25. I put that into the calculator, get an answer of 6.4488. So answer 6.43 meters. When you're dealing with questions, at that point it was safe enough to round up to 11.77 because it was 11.770. Future, don't round up too early, as overall it may lead to some rounding errors. So now let's just go and look at the next question on that. Again involves trigonometry, involving a circle this time. So in this question you've got a large circle and a smaller circle, and you have tangents to the smaller circle OA and OB, which are the radius of the larger circle. Well, if that's a radius, then what you could start doing is just start filling in some information there. You know that that line, based on a previous video I've done, is perpendicular to the tangent OB, so that is also the radius, because we know that a tangent to a circle is perpendicular to the center at the radius. So that there is our radius. They're both perpendicular, so they're both the same distance. So here we've created two congruent triangles. We know that if OR and OR are the same distance there, then these two angles must be the same. And if BOA is 60, each of these must be 30 degrees. So the ratio of the area of S, which is our large circle, to the area of C, which is our smaller circle, is some number k to 1. Find the value of k. Well, we know that the area of a circle is pi or squared. So it's going to be pi or squared compared to pi or squared. That's our radius. So it's going to be or squared to or squared. So if this is S and this is C, all we're doing here is comparing the radius of the two circles. If we can find the ratio of one radius compared to the other, then we've found essentially the ratio of their areas. So we're really going to just be looking for some information about the radius of the circle. I've said that that's 30 degrees. We know they both have the same side, which I'll just put in pink here, OD. If I look at that right angle triangle, then the sine 30 degrees is equal to OR over OD. And the sine of 30 degrees is a half. So OR over OD is equal to half. So therefore, OD is twice OR if I cross multiply. And if I want to know the radius of the large circle, which I'll put in blue here, OC, that distance there in terms of OR is going to be OD plus OR, which is the radius of the small circle, because that's the radius there. So if OD is twice OR, then OC is going to be 2 OR plus OR, which is 3 OR. So essentially the blue radius here is the radius of the large circle, and it's 3 times the radius of the small circle. And if I go back up here, well, the ratio of the area of the circles is just the ratio of the radius of the two circles squared. So we're going to have radius of S is 3 OR radius of C is OR, so therefore area is going to be 3 OR squared to OR squared, which is 9 OR squared compared to OR squared. So that's a ratio, taking OR squared out of it, of 9 to 1. So therefore the value of k is 9.